Hey class, good morning. So want to walk you through the last part of the most recent assignment on 11.3/11.5 for the sales grid analysis work that we're working on. And actually before, so we've got this, I asked you on October 29th that we download the sales analysis file from the GitHub and then run the commands one by one. So we're going to, right, and there was a classwork associated with this. So you're supposed to download this data file and run these. So I'm asking you to grab this sales analysis file, and then we got a clear screen. And I'm gonna, one moment here, I'm gonna just turn off me for a minute so you can focus here better. And then I'm gonna back to my sharing screen. Okay. Make sure my volume, just want to make sure my volume is all the way up. Okay, so you're supposed to download, so this is October 29th, and I asked you to download and run the sales analysis.python. So in class, first thing you're supposed to do is download this data file using the curl command. You're supposed to download this data file. And then we talked about that here. And I think we talked about that even in an announcement prior to 10/29 on 10/22. Yeah, so we started talking about downloading files and using the linear regression. We did the Pandas profile report on this data file already. So you should already have this data file multiple times by now. But again, if you don't, grab it right here, unzip the data file, and you should zip it into a location that you know. And then we use this pickle command to make a data frame. So in class, we exported the data frame from connecting to a database, right? We SQL'd it. I connected to a database on my own machine, connected to the database, ran a query, pulled you a data set, and then pickled it, and then put that pickled object out where you can download it. Okay, and then we wanted to start being able to, we want to look at the data first, but like correlating, like they did with the Boston data in chapter 6. And this is Volusia County sales data. And then you should run the Pandas profiling report and what have you. So that was what we were doing about 2 weeks back. And then on October 29th, I'm sorry. So then the next thing we did was we merged data frames. So more on pulling data files. And then we did this merging. So we had the sales data and then we merged it with GIS data. And we used this Pandas merge command to merge the data frame of the sales data with the GIS data to produce GIS data with our sales data. And then we did rows and columns. And the last part of the assignment was to build that sales grid, which you guys did. Because now you're into the last piece. Okay, so that was a little bit in 10/27. Then 10/29, okay, we're downloading that sales analysis, and then we're going to start looking at some of the code. So I just want to peek real quick on 10/29 on this sales analysis. So we downloaded the file. We're going to import it and then unpickle it. So let's just do these first few commands. So we had downloaded the sales data, unzipped it into C:temporary. The file name that's part of the zip file is salesdata.zip. And then we use Pandas to read a pickled object and create a data frame. And that pickled object is stored in file name, which is this file name, which is associated with this file that you downloaded and unzipped. So now you should have the data frame sales data frame. If you do not have this, you need to contact me right away, because if you don't know how to get here, you are, then, you're in a little bit of difficulty. Okay, so the next thing we do is then we run the data frame correlation. So let's rerun this correlation. So data frame correlate, and up comes this grid. And then, having gone through some of this before, here's a correlation matrix in chapter 12 that does something. It does a different, it's doing stuff with diabetes, I believe it is, yeah, diabetes. And these are the different factors of diabetes, ... And then they do a correlation matrix, and they print this correlation matrix. And we saw this in the last video and the last class, as far as building like a sales grid and plotting it and color coding it. Okay, then the next thing we did is, all right, well, how do we get, the data that's associated with zip code 32114, right? So we asked for, so this is using, we're trying to access the data frame and using the Boolean arithmetic to get a slice of the data. I only want to show elements of the data frame where the zip code is equal to 32114. So that's an inner bracket. So this is going to return me a list where this is true. If I only ask for this part, this is going to evaluate all 44,633 records of the data frame and give me a vector that says true and false for all 32,000, or I'm sorry, for all 44,000 records. So if I run that, it tells me there's 44,000, the data type's Boolean, and it says, hey, true or false, if that's true or not, that it's zip code 32114. And now if I bracket that, say, okay, this is the list of trues for that data frame. Now there's 1,200 records, right? If I ask for the length of this, there's 1,283 records where that is true. And now I've got like a slice of data where that is true. Then the next thing we said, well, how do we get the unique list of, zip codes? So that's what, did next. And then we got this value counts, so we can go through and find the zip codes and their associated values. And then we got these weird nulls at the end that we tried to strip out, and what we did later. And then you could do stuff like sort by the index. So in this case, we're going to sort by the, we're going to run that code, that same code, but we're going to sort, grab the value counts, but sorted it by the indexes. So 32102 becomes, right, and we got a numerical sorted zip code, but the values are, wherever they are. And then we could sort by values. And now we have an ascending ordered list. Okay, so that was the first part that we were working on 1029. So then we said, okay, well, how do we find the three, next add to the query to run for 3-bedroom homes in each zip code with the same criteria. So generate a table listing each zip code and find the min, max, average sales price per zip code. Okay, so I'm sorry, part one was to find the min, max, and average. So using that same logic, we can get the mean, min, max, and average. And then we wanted to do it for each zip code, right? So that's kind of, we want to loop over that list of unique lists, right? And so you could do something like, oops, right, for zip code in data frame bracket zip 1 dot unique colon print zip code. It's going to print me each zip code on its own line that are in that list. So now you have it, and now you can go through and do something with it, like add another line to it and say, okay, well, give me, you know, print the mean price where that zip code is, you know, so the same thing. So do the data frame where zip 1 is equal to that zip code in that list, and then give me the sale price mean value. So I printed the zip code. It's going to print the zip code on one line, and the next line that's going to print is going to be the mean price for each one of those zip codes. All right, and then we get the mean, min, max. So you probably want to store that. And then we made this nice little plot. So we went through each zip code and then calculated the min, max, and what have you. And then over here, I give you an example of how to do that, right? For zip code in the zip list. Okay, so what is zip code in the zip list? Same thing I just did, that same query, right? We could assign that zip list equal to those unique values of the zip code. Data frame dot zip 1 dot unique. So now I've got the zip list, and it gives me this array of objects. Now it says I can't do anything with that in Spider here. Okay, so now that brings us into the next set of slides here. So if you haven't got that homework done yet, well, jump in here, and I'm giving you, so this set of slides. So here's the idea. Most of you guys that are in class every day are probably have already done this and had no problem. So under the announcements, under gridding and plotting, what we're doing now, here's these slides here, right? Plotting the zip code polygons, and we're going to pick up here. So recent classwork, querying the data frame. So we queried the data frame, and then we accessed all these zip codes. And then I'm suggesting that now I'm trying to get the mindset into plotting the zip codes with their associated polygons. So from the GIS side, last time we downloaded the zip codes Polygon, I can get these polygons from GIS, and these zip code polygons, these are just the zip codes. These are the polygons that are associated with the zip code. And a polygon is a array of points that define a boundary, right? So there's like 100 little points inside here that define this little boundary. And I wish I could click, I don't remember what the button is to click to get it to show you the whole list of points. I thought it was just select features by polygon. Oh well, that doesn't really matter. I just wanted to show you those little points. Maybe I can get it from here. Oh well. But you can get the array of points. And so I do that by exporting the data elsewhere in these slides. So I'm not expecting you to know how to do this. I'm just showing you that I exported these zip codes out. I downloaded the data from Volusia County. So Volusia County has a volusia.org/GIS. Goes to this Geographic Information Services website. and I downloaded data, geospatial information systems, and I've got these countywide shape files. And I grabbed the zip codes layer down here at the bottom. We got zoning layers, parcel boundaries, roads, mobile home parks, flood zones, golfing courses, all types of data here. And then notice that all the data is in this Florida State Plane East feet coordinate system. That way there, all the coordinates are in X, Y, are in feet, and all the points are in a positive coordinate system. So I can export this layer. If I right click over here, if I export and save these features as, I can dump this data out into other shape files or comma separated value files or GeoJSON. So if any of you guys are going to use Folium, you could dump this data out into GeoJSON so you could load that data up in Folium. So I've gone through and exported each one of these zip codes. So I've downloaded the data from Volusia, kind of the same, using that same curl command. Unzipped it just like I showed you. And then I'm using this Postgres database on my machine, which I use for my CS540 class. So I'm going to extract, I'm going to use shape to Postgres, and I'm going to dump it into this coordinate system 2236, which is associated with Florida State Plane East. I'm going to make geometry out of the zip codes.shape. I'm going to call my table GIS zip codes, and I'm going to create, so it makes my create SQL syntax. And then I run that create SQL syntax, and it generated me a database table called GIS zip codes. And then I requery that table with SQL, and I ask to select the zip code and the boundary as text. So it's going to go through and give me all the points on the boundary for each zip code where the number of rings is equal to 1. Polygons are kind of complex, but basically it's an array of points. So when I only want to deal with things that only have one ring, because if you have multiple rings, you have a ring inside of a ring, and I really just didn't want to deal with that inside of Matplotlib just yet. So the first thing I did is I just downloaded all the easy rings. And so I get this first zip code, and it says multi-line string, and then I've got a point followed by a comma somewhere. There's like, okay, so there's 2 points. There's an XY point, X space Y, comma, X space Y, comma, X space Y, comma, X space Y. So all the zip codes are in this XY space. So then I strip off some of the junk that I don't want from that text file. And again, that text file was generated by the export of that command. And then I open up that text file and just manually strip off these leading spaces, and then the space, and then that pipe sign, and then that multi-line string, and those first 2 double quotes or double parentheses. And I strip off the other parentheses at the end. And now I've got a zip code tab, and then a series of XY points. And then, so I'm explaining kind of how it works, and then we'll go back through the actual code. So now we've got these XY points. So I'm just going to I did one polygon to see if I can make this work. So Matplotlib has these things called patches. And then we saw this in chapter 7, which most of you haven't looked at, but me and Michelle Wynn are working on something for y'all in chapter 7. And they use this thing called patches. These patches right here, this red patch and this blue patch. And so we import these patches, and they make these patches. Oh, here's that. So we got a red patch and a blue patch. And so by default, I guess it made a little red patch and a little blue patch. So, but they already have this library built up. It's called patches. And Matplot, that's where I got M patches at whenever you see me use it. So this idea of a patch is basically just the ability to draw this little red box on the screen or a blue box. So that's kind of where this came from, this Polygon patch. So Matplotlib has this library called patches, and we're going to use the patch type Polygon. So I pulled just that first line from the file just to see if I could make this work. So I'm not expecting you to know how all this code works. I'm just kind of explaining to you what I did to make it work. So I grabbed the XY points, and to make a polygon patch in Matplotlib, you have to have an array of XY points. So I had this, here it says this point array of 393 elements. So in this particular zip code down here in the bottom left, I think, I don't know which, there it is, that looks like it. Here, right? So there's 393 points in this to make this polygon. So I wanted to see if we could do a kind of a complex polygon before I went any further. So I grabbed that string, I used a split function. So if when you read a line from a text file, it's going to treat it as a string. So I just said, okay, I just grabbed that first or one of these lines from the text file. And I guess it was, what was it, 32754, whatever. I grabbed one of them and put it in the code and said, okay, let's see if we can make this work. And so I stored as a string, and I'm going to point string, I'm splitting on the comma. So every time it sees a comma, it's going to make a new array. So I'm sorry, each time it sees a comma, it's splitting that string on commas. So you're going to get however many point strings, how many point pairs are there, are split by the commas. And I'm going to loop over that whole list of comma separated values. So for I in the range of the length of points is, we split on comma, so there's 393 of them. I'm going to loop over that whole list, and then I'm going to pull out the X and Y value, force those values to be of type float, and then append them to an array called the XY array, which is right here. And then I'm going to make a polygon patch on line 26 there. I'm going to make a polygon out of that XY array of points. And then we use that same code as we used in this figure and axis that we saw from the prior video, as well as from chapter 12, where they made this plot here with the figure and axis subplot, allowed me to put the size of the grid that I wanted. And then I set this to 10 by 10, and I'm going to add a patch. So this is a new command. So I've got this plot bar. So I got the figure and the axis, and we're just starting with our first plot. We set the plot size to be 10 by 10, and then I add a patch. So that's a function that's part of Matplotlib called add patch polygon. And I added one patch to the plot grid. And then I said, okay, plot it. Boom. So we created the polygon. We created the polygon by reading this array of points. And then we made one polygon. We used the Matplotlib patches utility. This guy, patches had a function called polygon. Polygon said the way the polygon method function works is if you pass it in an XY array where it's closed. So we've got this, set of points. It's called a closed ring. And if it's true, it means the last point is equal to the first point. So wherever the, right, you got all these points. And typically it's in either a clockwise or a counterclockwise method. And we go all the way around and we set the first point equal to the last point. Boom. And so it's a closed polygon that's true. And what the benefit of a closed polygon is, if you, by you attach it, now you've trapped this area and you can determine what's inside of it and compute the area of an arbitrary shaped polygon, or the perimeter, or all types of geometric functions that can now operate on this closed area called a polygon, all this trapped in area. And again, the other benefit of us working in feet is, right, if we calculate the area that's going to be in square feet, it's going to be big because it's, you know, it's a zip code, but it's going to be in square feet. And then once we made that polygon, we added that one patch. Okay, then when you go to all the polygons, it's a little bit harder. It's called a collection, and then we got to add that collection. So it's a little bit different than one polygon. All right, so then once we got one polygon working, and again, this is beyond what you have to do. I'm just showing you what I did. Now, once we had one polygon, I said, all right, well, now I'm going to read all of them. I'm going to read through the whole entire array, or the whole zip code file. So, you know, on my machine here, I've got this zip CD to MA305, CD to zips, I don't know, zips 2.zips.text. I'm going to open that up in Notepad. Plus, and then here's this, you know, array of points, this file of points. So I'm going to open up that file, read each line from the file, split it into its XY points, create a polygon. And then once I've created the polygon, now I'm going to append it to, I declare this initial array called patches. The square bracket says it's an array. So I've got this array of polygons. And I'm going to generate an array of polygons. And along with generating that array of polygons, I'm going to store a dictionary. I'm going to generate a dictionary. A dictionary is like an array, except for when you define an empty array, you use the squiggly brackets. And what a dictionary does is it maps it's like an array, except for it's not index based by numerical 0, 1, 2, 3. It's actually indexed by strings like this. So I'm going to make an array that maps the polygon to the array number of which polygon is it. And then I go through and I actually run this code. So if I do this code real quick for you, and again, this is beyond make plot zips. So test plot, no, we did sales analysis. We don't need the test plot polygons. We don't need this. We don't need that. Okay, so I'm just gonna open up plot polygons, read zips. Read zips. Okay, so here's the code that I use to read this zips.text, generate the polygons. I want to get rid of everything and then just run this code. So it goes through, it finds all the polygons and then just arbitrarily picked a color map by random colors. But it generated this array of polygons. sorry, let me think a minute here. That's a single polygon. So this is the last polygon. And then I called that patches, which was a array of polygons. So here's my patches. And over here it's saying polygon, 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 and there's 34 polygons. There's 34 zip codes in that array. Okay, and then patches.polygon is one singular polygon. And I was telling you there's like this XY array of points. So these are the points, the XY points that it created the polygon from. Okay, and then I pickled all of these polygons for you so that you don't have to deal with this part of the code. All you got to do is run the plots. But with these polygons, to plot them, when you have multiple patches, you have to use a collection object. So I have to use a patch collection. The single polygon was a single patch. Now I've got a collection of patches. I'm going to use a color map. And then it sets the array of colors. So what in this case, I just used a random array of values for the array. And then I add the collection. So we call it patch collection. Set the array of colors, sets the color associated with it with a random number, and it uses this random map. Add that collection, and then I've added that collection to the axis. So I literally stuck each one of these polygons in the collection onto the map. And we use this function here, set array, to set the colors. All right, so that's what I did. What I'm asking you to do is use this code. So I pickled up the polygons for you. If you ever watched Mr. Popper's Penguins, I was trying to pickle the polygons, please, Peppy. So I pickled them. You can download these polygons. And now we're going to try to make a colored map. So I've asked you to run plot polygons. So you've unpickled the polygons. And I've given you this code, plot polygons.py. Right? Plot polygons.py. And what it does is, let's clear it and let's run it. Okay, now it told me zip list wasn't found. First thing it yelled at, zip list is not defined, which is perfect, because what we've done here is showed the first part of this code works. I don't have a zip list to color my polygons, but what it did do is load in the array of polygons. And what it did do was it plotted them for you. So you unpickle, you set up your plot grid. We did the same thing as the last class where we showed the zip code map. And now we're going to add a patch collection of polygons. Again, these polygons are an unpickled. You unpickle these guys by reading the file in a binary mode and create this polygons array. So before we did a data frame pickle, now we're going to do just some random object pickle. So polygon, I pickled a polygon array, and so I'm going to unpickle that polygon. It was patches before, but now it's called polygons. But now I'm unpickling that list, and I've got my array of polygons. And I also made that zip code polygon dictionary, which maps the zip code to the array element of polygons. So 32102 maps to the 12th element of the array, which is the 13th physical polygon in that string. And then to make this code work, we need to set up that zip list dictionary. which was what we were doing back in the beginning of this. Okay, we talked, the first part of this was making a zip code list. And then, right, so we made the zip code list. And then we made this dictionary element zip list inside your loop where you queried based on whatever you're querying on. We did the average zip code the average sale price per zip code. And we added that to the zip list. So if we go back to our homework, sales analysis homework, right? So we did the zip list, and I'm going to set my mean sale price for just the arbitrary zip code. So now I have a zip list, which is a dictionary. Now there was only 29 zip codes in this zip list, but there was 34 zip codes in the zip code. So some of these zip codes did not have a sale. And now if we come back and run plot polygons, we've got our map of what each one sold for and what the sales prices were. So the average sale price for parcels. So the blue ones, now I've actually hard coded this one just to make sure this worked, right? So we can put this, let's say let's uncomment this code, save. Let's rerun the other homework to populate the zip list. And now we can run the plot polygons. Don't clear your memory because you've got that zip list and now it's proper. So the darker colored blue ones are lower sales prices. And then the highest sales prices, I capped it at 400. No, I didn't. I capped it at whatever the maximum value was for sales prices in that zip, for all the zip codes. And then the minimum value was capped at minimum. And as long as the value was greater than 0, then I grabbed the minimum value. Right, so what does that mean? Let's grab that. What is that? So what is the minimum value? Okay, so it took, I think I missed a piece there. Oh yeah, I missed the min. But color, these were all the color values where the color values were greater than 0, and I want the minimum of that. I want the minimum of that array. So the minimum price was 123,000. Because if you just grab the minimum of color values, 2, you got 0. Well, I don't want to have 0 because it goofs up your gradient. So if this is too high or this is too low, you're getting warped and it kind of goofs up your gradient. So of valid sales, I set my lower limit to the lowest valid average price per zip code, and I set my max to my max. That way there I give a reasonably good gradient. And then up here I was just testing it. So okay, well, let's see. Am I sure it works? Let's change 32124 to be a different value. 32124. Let's just force this to be 500,000. So this is going to turn red here when I rerun this code. 32124 turned red there. And I was just testing it just to make sure it worked on a zip code by zip code. And then again, you generated the zip list. dictionary, which maps your sales price to your zip code. And then this code goes through here and it says, okay, for each polygon, if that zip code is in the zip list dictionary that we made from our sales prices. So if the zip code from the Polygon dictionary is in the keys of the zip list, then I'm going to grab that value, zip list, grab the dictionary value that's associated with that zip code and set that equal to your color value. If it doesn't exist, set the value to 0. Okay, so we set up an array that color codes each polygon to its associated value that you calculated over in your homework. And that was the reason why we made this dictionary object over here. The key is the zip code, the value is the price, and then we set up this array of color values, and color values is going to match the length of polygons. Color values. So there's 34, right? And some of these are 0. So either by default or doesn't match or whatever reason. And right in polygons, there should have been 34 of those as well. And so we associate those two by this function here, and then we set the array. And then this color limit is where we apply the limits of the color range, kind of like we did when we recolor coded the sales plot. So the minimum value is the minimum, what we just did over here with the the minimum price. So that's the VMin and the VMax. And which color chart did we use? We used VMin, VMax. We did it with the polygons up here. So I'm using the color map plot, the jet one, which is a little bit different than I used elsewhere, but I'm using the color map jet. You can use whatever color map you want. Down here, you can look for, sorry, it's at the end of the slides. I provided you a link in the prior slides of all the references. So sorry about that. I know I'm doing two things at once, but so you can go back and look at all the different color maps. And I'm sure I've given you that link multiple times, but we could quick Google for color maps. Matplotlib color maps. Using a color map. So you got multiple color maps you could choose from. And you can change the color map. Here I use the jet color map. And I set the transparency to be 0.6. And then we run that code. It uses your pricing that you set up per zip code. It pulls in these polygons and then color codes these polygons based on that price and that color map. All right, so most of this code is actually done for you. I'm just was walking you back through how it all works. So as you're trying to put this together now, we're here in the slides. We're down to slide 20. Here's the code to make this all occur, but I've also given it to you to download, so you can just download this code. Right, so I've given you the plot polygon code. You don't even really have to do too much here. Just run it. Set up your color map I walk through all, how all the pieces work, generate your color map, take your screenshot, maybe change your either change your color map. You can also change your query from your homework. Do you want to do like 3-bedroom houses that are single family residential, whatever you want to plot, generate your values, and then run your plots. And then later, if you wanted to extend this, Folium is a way of doing this in Jupyter Notebook, and GeoPandas has libraries for doing it. Trouble is all that stuff's in longitude, latitude, and a lot of the stuff that, it's nice to be able to deal with feet first. And when you understand the concepts here, then you'll be able to deal with the GIS a lot better. All right, well, I hope this helps you get through your homework. Hopefully you guys have learned more about querying the data frame, where we've got this indexing, we've got this, right? This first criteria here that, forces this to be just this zip code. And then I want to grab the feature within the data frame where this is true, and then grab the mean price, min price, max. Then you go into the next one. We want to add more criteria, right? Where the zip code is this, and it's waterfront, and its bedrooms equal to 3, and its land use code equals to 001. And then you could run that code, boom. And then set up your prices, load in your polygons, and make your plot. Okay, that should be about it. And then you should have a pretty good idea about plotting and doing this process. All right, I hope this is helpful. Make sure you capture your lessons learned, and we will see you on Tuesday. Please do not hesitate to ask questions. Drop me an email, drop in the Zoom. Let me know. Have a great day.